Yeah, Chris uses Elixir and Rust to do renewable energy things, and he also has a few libraries that you might have heard about. And you're going to hopefully learn some stuff from Chris right now. Everybody give a round of applause to Chris.
Well, it is good to be back here again. This conference always holds a really special place in my heart. I live here, for those of you who don't know that, and so it's always so great to have people to town to like be able to celebrate everybody being here and to have like all my friends get to come visit me, and that's awesome. So I hope this isn't like a weird flex, but apparently I have kind of a reputation. One of the things that gets thrown around a lot is that he's overly opinionated. These are real Hacker News comments about me. And actually, here, while we're on this subject, if you wrote this, I just need you to know, I have feelings. I'm a human being. But I love this. If you want, you will have no idea how long words like, plus I often find myself wanting to prove you wrong. And then I end up doing a bunch of, you know how many months that lives rent-free in my head? I've also been called anti-community. Languages have idioms for a reason. Oh, sorry, I need to become this person. Languages have idioms for a reason, and a lot of these suggestions go against idiomatic Elixir. I think people think that like when I talk about design, which is the thing I talk about a decent amount, I think they think I'm like taking the piss, like that I'm not really being serious, that when I say things like it's tongue-in-cheek or hyperbolic, but I actually do believe and do the things that I talk about. And so in this talk, when we're talking about the philosophy of designing things in Elixir, we're talking about things that I really do. Like I'm gonna tell you stuff that may feel unidiomatic, but it's genuinely because I think that they build simpler systems. And I've given talks like this in the past. I decided to give this talk sort of again because apparently I was shown this screenshot of some code and y'all didn't freaking get it. Not y'all in this room, obviously, someone else. But but enjoy this with me. I need you to let this wash over you. You will notice a case with up here at the top. I've never seen a case with before. But it's one of the greatest things ever. This is art. The piece de resistance, the thing that really drives this over the edge for me, A to A. I love it. This is the best thing ever. Anyway, somebody sent me the screenshot of this code, and I just think it's hilarious. What this talk's really about is how to write simpler Elixir code. And like I said, I've talked about this a lot, but this time it's going to be way more practical, because I'm going to show code, which is something I don't normally do. And also, we're going to need a little audience participation. So I have a mechanism for this. We're not going to raise hands, because often people raise hands and they feel like kind of singled out, or it's like, I just want to be like anonymous. Like I don't want to, you're saying some weird crap and like I don't want to like get in on that. So instead what we're going to do is I'm going to present some slides like this. Yeah, you're close, very close. If you agree with these statements, I would like you to hum. You've all learned very well. This is great. Also, I will note, not humming is a tacit sign of dissent. So you get to pick yes or no. So let's try a couple of these. Erlang and OTP are good tools for building concurrent systems. Cool. You're really enjoying this talk so far. Very good. All right. Short functions are always better than long functions. Interesting. Editors should always be run inside of a terminal. Yes. What about this? P does not equal NP. Oh, interesting. So a lot of you believe the world doesn't make any sense. Good to know. You don't need comments if you have well-named functions and variables. Statically typed languages produce more reliable programs. Okay. XP-based leveling provides a better player incentives and a tighter game loop than milestone leveling. I agree. Thank you. The formatter produces very elegant and easy to read code. Piping into case is dumb. Okay. All right. These are just for you. Piping into case width is always allowed. And encouraged, actually. Okay. Why do you think the things that you think? This isn't... Okay. Do you think the things that you think because someone told you? Because of lived experience? Because you read a book one time? Because there's a fancy acronym that tells you you ought to think that way? These are good questions. I think this question, why do you think the things you think, is something that like we ought to really, really consider. Because this is what's going to drive the work that we do every day. The problem is like, this is also really hard, and most people don't have a foundational sense beyond acronyms, beyond easy to reach for like ideas that they can bring to bear on any given problem, which is what gives rise to garbage phrases like, well, it depends. You know what I hear every time someone says, it depends? Well, that sounds like I'd have to like do my job. Yes. Of course it depends. You might as well be like, oh, it sounds like we're going to have to write code. Well, yeah, probably. How are you going to go about writing code? Of course it depends. What else? Let's get past nonsense like that and start having a real conversation about what we're about to build, how we're going to build it, what are the tools we're going to bring to bear. And so this is the kind of thing that I really want to tackle. And I'm going to help you hopefully understand a little bit about how I personally think about design and how I personally think about building this stuff in Elixir. So if we're going to build simpler systems, we need to agree on a few fundamental premises, a few conjectures, if you will. Premise one, software design is fundamentally about managing complexity. Yeah, okay. That wasn't a question, but sure, yes, I agree that I'm glad that everybody agrees. And I specifically mean design here, okay? I'm not talking about like writing the code or using your editor. I mean specifically software design. It's about managing complexity. And I will demonstrate this by talking about, if we're going to talk about complexity, we need to talk about a little bit about what complexity is, like what it means. Because we're not also talking about exploring the solution space and finding suitable solutions and then doing all of that stuff. That's all part of it, but in this case, what we're really talking about is like, how do we construct the layers in our system? So for instance, if we're talking about an HTTP client, there are things that you have to do in order for it to be an HTTP client. For instance, you need to do socket management. You might need to handle SSL or TLS connections. You probably want to do connection pooling if you want it to be efficient. You will need to care about things like HTTP 1.1 versus HTTP 2 versus HTTP 3. You will need to parse HTTP payloads. Potentially, those are like text. They might be binary. You have all these different parts of it. And this is all what I would call the essential complexity. This is what you have to do or have to actively not do. You could not do connection pooling. That's a choice you can make, but you have to make that choice. You don't get to not make that choice. If you don't do any of these things, you haven't built an HTTP client. So that's what we're going to call essential complexity. The total complexity of a problem is the sum of all of the essential things that you have to do multiplied by how much you have to actually interact with those things. How often do you actually have to deal with connections? How often do you actually have to deal with parsing? And most of the time, this interaction point stuff is going to be in the form of dependent code, what we're going to call dependent code. Some people use a different word for this. They call it coupling. And I think we're all familiar with the term coupling. And if you're not, it just means two things that depend on one another, whether by shape or by signature or by usage. For instance, here, module A, if you make a change here, you necessarily have to make a change in B. That's a coupling point. That's a dependency. The second premise is that all code has a cost. Every line of code you add to the system adds cost to the system. Cost in cognitive load, cost in understanding, cost in interaction points. It all adds cost to the system. It also adds value, ideally, not necessarily always. And so anything we add to the system should add significant value as to outweigh its cost, which I will demonstrate with this hopefully very trivial mathematical equation. So, my question to you then, do you agree with these conjectures? Okay. If you don't, we actually don't have much more to talk about because this is what I personally think about design, and it's how I base everything else I'm going to do. Everything else falls out of these two ideas. And everything is going to be driven by these two ideas. So hopefully, if you don't agree now, that's fine. And maybe by the end of it, I will have convinced you. Or not, and we can debate this over whiskey later, which sounds pretty fun. I'll at least have one other person. So if we agree on those ideas, let's dive in and actually talk about how we do this in Elixir. So we'll talk about designing modules. So we said that the total complexity of the system is based on the sum of all the essential things you have to do multiplied by interaction points. Now, it's been a minute since I've used math, but I'm pretty sure if I can get those interaction points to 0, I can actually start to eliminate complexity from my application and just not deal with it anymore. And we do this by a word that I think we use in lots of cases. We do this by encapsulation. It's not just for your state anymore. Now it's also for the complexity that you're dealing with. So we think about our HTTP client. When I'm dealing with their HTTP client, I don't want to care about anything underneath it. So if I'm dealing with TCP, I don't want to know anything about it. And likewise, if I'm building some client that uses HTTP, and I use things like Fuse or adaptive concurrency, I don't want to actually care about the HTTP underneath it. And if I have to, well, that kind of speaks to potentially a mismatch in design. Something that we see when we think about layering systems this way is that everything at the bottom is like pretty general. You can reuse it in a bunch of different, think about all the things you can do with TCP. And as you go up, it becomes much more specific, and you actually lose reuse, right? So things at the bottom are going to be more reusable, things at the top are going to be less reusable. So this is kind of what we want to think about when we're building real systems, right? When we're starting to think about the layers in our applications, like what of this is generally reusable, what it needs to be generally reusable, or what can be more specific. So, how does everybody feel about this? Cool. So, this is an example of, well, like, this sucks. So this is a bad example, right? This would be an example of what super not to do. Because obviously, if you just want to make an HTTP request, you don't actually want to have to care about all these other submodules and garbage and make your own connections and send things and receive things. And this probably won't even work for certain versions of HTTP potentially. And nothing about this is good, right? And obviously, I think what we're probably all used to is something like that closely resembles this, right? Like there's some module, have some function on it, and you get to make requests with it. This shouldn't feel like that weird. And yet, this is the kind of code I see all the time in applications that I like walk into. There's like numerous under modules that you have to like dig down through to like do anything actively useful with it. But at the end of the day, like I don't want to care about any of this stuff. And actually caring about it necessarily is harder to deal with. If any of those things changes, you broke everybody who needs to care about this stuff. So hopefully this is a little bit self-evident. Maybe one that's less self-evident is something like this, which is like the pattern that like shows up in many, many MVC applications. So you have some controller that calls some module, which calls some schema, and maybe calls a repo thing, and then talks to the database. And at the end of the day, like, I think the question you have to ask yourself is like, what does any of this junk in the middle do for you? What, like, is this hiding complexity? Is this actually removing complexity from your life? Is it actually hiding the underlying things that you're dealing with? Is it actually hiding away any of the results that you're dealing with? Like, and maybe a more pertinent question is, how often do you actually have to go touch these things? Like if you make a change in the schema, what else has to change? Do you change a form all the way out in the view? Well, like necessarily nothing's hidden. We have not encapsulated anything. We've allowed complexity to spread through every layer in the system. And furthermore, when we like are dealing with stuff that's coming back out of these schemas and results, like how much of this information underlying here gets back into the controller or even deeper? Like does it get all the way back out to the user? In some cases, yes. I would remind you of our second premise, that value needs to be much, much greater than the cost in order for you to want to keep the layers in your system. And so in these kinds of cases, like if you're dealing with lots of cognitive burden, the easy answer is to remove all these modules that provide little value, that do not hide things, or to collapse them into something that does hide the complexity underneath it. So, we'll see how we're doing here. A little temp check. Modules should hide the complexity underneath them. What about this one? If every change requires updates to multiple modules, your design needs work. All right, there we go. So we talked a little bit about modules. This is how we're going to start to layer the application together. Now let's talk about functions. I need to take water before we do this. All right. So I have a function here. This is this is going to get a blog post, let's say, and we'll look and see. It's going to do this check fuse. It's going to check a circuit breaker and then call or do a fallback. And it looks like we passed some like anonymous functions in here. And you imagine you're new to the code base. You're new to this company, and you've been brought in to look at this stuff. WTF does this do? How does this work? I mean, it says it's using fuses, and let's just presume that everybody happens to know that fuse means circuit breaker. We see this caching stuff, but it's like, what fuse are we even using here? There can be multiple in an application. Like, how does it get blown? Does it ever get blown? How do we update the cache? Like we're clearly like serving from cache and updating it, but like how? And what cache are we using? Like what's happening? So the only way to figure this out is to go read lots of code. So let's go and look at this thing. Well, this thing looks like, okay, we figured out where the fuses are, cool. And then we call these things, that's cool. But like, what else does it do? Well, now we gotta like, it doesn't even fit on the screen anymore. Now we've gotta like roll down and go look at this. And it looks like, okay, if we call the up cache, it looks like that's what we're doing the put. Oh, look, there's the melt. That's cool. So if it errors here, and then when it does the get, it does a get and then returns the result. Or it returns not found, which I guess is gonna get shown to the user somehow, like 4 functions deep. Cool. So, question. Who thinks this seems very simple? Y'all are doing great. Yes. And I'll point out, I did write this, and it's, obviously like a straw man, but like I really tried. Like I did my best with this. It also has all these questions of like, okay, but what if this thing needs to change? Like we always want to serve from cache first, because like calling this service is just so expensive, we can't keep doing it. What if like we just want to like change how we deal with errors or whatever, right? Like how do we want to like, maybe we want to blow the fuse more often or only on 400s or whatever. And if we change any of these functions, are they going to affect anything else that's in this module? Like those are presumably private functions which get hopefully reused, because why would you have a private function that gets used in one place? Yeah. So we end up with this like sort of this large problem. And the thing I would propose is that every function you have should do one thing and do it completely. So in the case of getting a blog post, I'm going to show you a very quick fix. It's really great. You just do it all in one function. And yeah, the function's a little bit bigger, and it's got some nested case statements. But guess what? I can look at this and go, yeah, those are the fuses. Cool, got it. I see how the fuse is getting blown now. That's great. I see where caching is being used. That's all right there. Excellent. That definitely is what I would want to return the error not found. And if I need to change this thing, I just change it. And it does not affect any of its surrounding code, although it may affect its callers. Okay, temperature check. Having complete functions is more important than the function's line count. Less people. Some are not swayed, which is fine. That's fine. The other, yeah, okay, so we need to talk very quickly about the deaf delegate in the room. Remember when we talked about this? Y'all remember this? Value should be much greater than cost. So why in the world would you ever write a function like this? Like what is this doing for you? What value did this bring to you, right? Like it doesn't. You just call the thing that you need. Like you don't need to wrap like one-liners everywhere, right? Like because it's not actually doing anything. It's not providing value. Like blowing a fuse, guess what? If you don't know what fuses are, saying blow fuse does not make any more sense than fuse.melt. Like, so you haven't conveyed anything here. Likewise, don't ever have modules like this. Like, what is this doing for you? Like what is this providing to you, right? Other than like, oh, I've got my version of it, and now I'm calling the repo thing. If y'all think I'm joking, I saw this, like the other day. This is a real thing. This is not doing anything. These are false layers. They're not like real abstractions. They're not hiding complexity from you. So don't add them. Like don't do this to yourself. All right. So that's designing functions. And let's talk a little bit about designing processes. Processes get hairy, but luckily, all the rules are still the same. We don't actually have to change our thinking all that much. So when we're designing process APIs, right, when you're interacting with a gen server or a process of your own design or a gen statum or anything like that, the rules are still the same. The user should not have to care about what you're doing under the hood. Like it just fundamentally, you don't want to expose all the machinery back up to the caller. It's not doing anything for you. And so in order to talk about this, let's talk about a cache. So for instance, we might have some cache module. It might have machinery. There might be processes under there. Maybe we're spawning them. Maybe there's all kinds of stuff. And we may wonder, is this a process call, right? Guess what? Who cares? The great thing is like if you've designed this stuff correctly, you won't care unless you're trying to tune it or something. And in fact, many caches are going to be built this way, where you actually do puts through this one nice API layer, and it talks to a process in order to be able to do things like, a ring buffer or rolling things out of the table, but then all your reads are going to come out of an ets table. because ETS tables are fast, is really the reason. And that's going to be updating the ETS table and managing it. And so Gits don't go to this process at all. They just skip it. And at the end of the day, as a user of this stuff, you kind of don't want to know. You don't care. You don't want to expose whether this is like a cast or a call and then make some other module deal with it, because all you've done is split up all the complexity that you're dealing with. So the caller does not know about this. And your code can just look like this, right? This is one module. I didn't put the def module on there because it would just quite not fit on the screen. But this would be like my first stab at this. Now, there's considerations about this, and we could have a whole big long discussion about those considerations, namely that like you probably want to supervise the ETS table separately, and so it doesn't restart if this thing crashes, and et cetera, and we could talk about that. Then it gets more hairy because, unfortunately, supervision is tied to modules in many ways, and that becomes a real problem when you're doing this kind of design. But we're not going to delve into that too much. If you want to know more about that, that's like a whole big thing, and to be honest, I don't have great answers around all of that, because it's kind of fighting Elixir a little bit. So, but in general, all this junk should just be in one module. Just one big old module. And if it's couple hundred lines long, so what? Who cares? What's the difference between a couple hundred line module versus like 5 20-line modules? So, oh boy. This is the one where Bruce isn't going to invite me back. Okay, how's everybody feel about this? Separating pure functions from impure functions creates simpler designs. Okay, cool. The reason Bruce isn't going to invite me back is that I don't think that this is true. Not on its own. It can be true, but I will remind you of the math equation that we've looked at a few times. The value of anything you're adding has to be greater than the cost, and the cost includes all of the interaction points that we're dealing with. So we have to ask ourselves all the same questions that we normally would. Namely, how often do you actually have to change both the pure and impure version to keep kind of in lock with each other? And if you're having to change both, then you have false layers in the system. That you have separated things that ought not be separated. They can't be separated. And another question you can ask yourself is, can you change the pure functions without changing how you use and compose those functions? Can you actually manipulate the data structure differently in all these different use cases? Can you generally reuse that thing? Separating pure and impure is like impure. Did it autocorrect? I guess autocorrect changed something. So separating pure and impure functions relies on good design. Like, that's the fundamental thing. Like, separating pure and impure functions can be a great tool, but you still have to do design. It is not the end point of design. You did not get to a good design simply by doing that. You have to still do the design part and make the thing generally reusable, make it like sort of abstract it out and hide the complexity underneath it. So, so that is designing processes. And this is a whirlwind tour of things that I really do. When I really look at code, I really do write functions that are like 50 lines long, and I'm okay with it. I do not get squigged out by that. And I encourage people to think about this, like have one top-level module and just don't let anybody get underneath it. Like, that's it. It stops at your module. Think of the modules you're adding as libraries almost that you could like reuse in other contexts. And what you may find is that you don't have as many layers in the system as you thought when you think of it that way, which net results in less code and simpler things to work on cognitively. Designing simpler systems takes lots of work. You cannot rely on emergence. You cannot do design every single day and just hope that it works out. You have to put your hand on the wheel and like steer it in the direction you want it to go. And you don't get to take a day off. You always have to be doing this. And also, there is no acronym in the world that will save you from this. You have to use your judgment, right, about what's going to make a simpler system, what is going to remove complexity. And it's really hard. I think about this a lot and really struggle with it. And I've been really happy with maybe one thing that I've ever built. But the good news is, for whatever it's worth, I believe in all of you. You're welcome. And I thank you very much for coming and listening to me today.